Okay, so you can see me. All right. Do I sound okay? Can you hear me all right? I know there's like a 15 or 20-second delay for me to even know whether you can hear me right or not. But let me know if you can hear me or no. So we're going to start at noon, so 3 more minutes here. I turned the volume down a little bit. I felt like I was clipping last time a little bit. So I turned the volume down just a smidge so I don't clip. But the flip side of that is that no one can hear me talk because I mumble all the time. So let me know. Because OBS thinks it can hear me. So I got that going on. But let me know. Let's see here. Okay, cool. That's all right. All right, so I'll start in 2 minutes, and I'll explain what in the world this is. In just a second. See, most channels would have some sort of like countdown thing that we have, but we're not cool enough for that because we spend our time trying to build activities rather than, you know, video quality, but we do what we can. It's white noise. Some sort of white noise. When I'm typing on my computer, is it super loud? When I'm putting keys on my keyboard? Yeah, we're starting just a minute here. It seems like this is the mic that's happening, so. Alright. Okay. So close to starting. Silence the phone. Boop-a-doop-a-doo. All right. Okay, it's noon. We can dive into it. I can tell you about our data science curriculum that we're still building. I want to show you something that we built for a data science mini course at Metro High School that we did just earlier this year in January. Before I do that, a couple announcements. So one is that the STEMcoding project has a new Discord server, and this is intended to be for teachers for the most part, teachers and educators. So like if you're an after-school program person, you're still as much of an educator as anyone that I know. So that's kind of the intended audience for the Discord, and so that gives people a chance to interact with us and interact with each other, and the folks running the stream can potentially I believe that they're going to put a link to that either in the chat or in the description, something like that. So we encourage you to join that. A lot of people are hopping onto that the last few days. The other announcement, today is July 24th, but this Friday at noon, instead of having a live stream, so there's not going to be a live stream on Friday, and instead of that we're going to have a Google Meet session, and the idea is especially for teachers, instructors, educators, whether college educators, high school, whatever, to have a session with us, because we just posted some new videos, which I've already kind of told you about if you've been following the live stream. But we just posted these, and so we're kind of all out of videos that we've recorded and have been sitting on waiting to edit. So we've caught up with all that, which is great. And so we need your advice on what new activities to create and what videos to record. And we have our own ideas of what we would do with the time that we have. But an even better idea is to listen to what you think and what you might actually use in your classroom. And then ways that we can help each other. If people out there want to help record videos for us to analyze on the object tracker, we'd really love that. So that's going to be Friday at noon Eastern time. Instead of this live stream, there'll be a Google Meet link. That Google Meet link will be on the Discord if you'd like to join that. So that's the big announcement. Now today I'm going to talk about two different things, and they're both kind of related to environmental science. So one is going to be environmental science, public health, that sort of thing. So one is a CO2 survey, which I'll talk about, and the other one is the Earth Day. So the CO2 survey, which I'll talk about first, that does not appear anywhere on the YouTube channel. It's one of the newest activities that we've created, and so I'll be sharing it with you for the first time in just another minute. The other thing I'm going to be talking to you about is the Earth Day activity, and we do have some nice videos on the Earth Day activity you can check out if you want to scan down the page here. So the theme today is going to be environmental science / public health, and we are planning to create more activities in this general area in the future. And so let me go ahead and dive into it. So the thing that you would need to pull this off in your classroom, and the thing that we're doing, is that this is a fairly affordable CO2 sensor. You can buy super expensive CO2 sensors out there. This one is pretty affordable. No one pays us to advertise these things or anything, but we found this one seems to work pretty well. Is it going to turn on for me today? Come on, buddy. We got to plug in. Oh, there it goes. So why would you want to measure the CO2? That's a good question. But this is the sensor, and in a minute I'll show you the Amazon link where you could potentially buy it. Again, this is not a product placement. We found this to be reasonably affordable and also reasonably accurate when it comes to measuring CO2 levels. Now, why would you want to measure the CO2? Well, I don't know if people have seen, I've seen this on social media where people will go into an airport and they'll have one of these CO2 sensors, and they'll be using it to try to see how high or low risk that it is that someone might catch an airborne disease. And it could be COVID-19, it could be the regular flu, it could be a cold, right? It could be any number of airborne diseases. And CO2 itself is harmless to humans. CO2 is a very stable molecule. We breathe it in, we breathe it out all the time. It doesn't cause a problem when we breathe it in and breathe it out at the levels that it is in the atmosphere. And so the CO2 itself is harmless, but the level of CO2 can tell you whether there's been a lot of people in the room, and that can tell you, a lot of people in the room breathing, right? And that can tell you what the risk of catching a virus from somebody else might be. So again, I see people going into like airport terminals and then taking pictures of themselves with their CO2 sensors and saying, this is not good. And there is a lot of people that have to worry about that. So there's some people are immunocompromised, where their immune system is not as strong as the rest of us, and so they have to be very careful. Or people that are pregnant, they have to worry about getting sick, and so they really worry about these things. Now, for a school, I mean, I think it goes without saying that we want to avoid another pandemic. We want to avoid shutting down the schools and things like that, or even just for the flu. And the interesting thing about school is that some of the schools that I've been in, they kind of pack the students in there pretty tightly, right? So some of the class sizes can get pretty big, and then you know, maybe the ventilation's not that great, right? And so measuring the CO2 can tell you something about how high or how low risk it is that when you walk into the school that you might get the flu of some kind. Now, CO2 is, and by the way, the link to these slides I put in the Discord channel, and so you can feel free to use these slides. Please consider these as Creative Commons non-commercial. So I am the author of these slides, and you can adapt it for your classroom as needed. And so that's the premise of why you would want to do this, is to try to get at public health, to try to figure out how safe or unsafe is your school when it comes to transmitting airborne diseases. And depending on the outcome of this data taking, you might decide that, you know, we need to have the fans on more, like the air conditioning, we need to run it a little bit more than we were, or we need to have windows open or something like that. These are possible changes that that you might come to from looking at the data for this thing. So that's why we're doing it, but at the same time you have to make it clear to students, just kind of double down on the harmlessness of CO2, right? Because you're giving them a sensor, you're sending them around the school, writing down these measurements, and you're worried if the number is too high, right? And so it's important to make it absolutely clear to the students that CO2 in and of itself is harmless. The thing that is harmful is carbon monoxide, and carbon monoxide comes from, like, basically if you have you know, cars pulled up next to you, or you have some sort of awning and the exhaust comes and the awning stays there. So your house has a carbon monoxide. Carbon monoxide is CO, right? One carbon, one oxygen, whereas CO2 is one carbon and two oxygens. And so CO2 is a much more stable molecule than carbon monoxide. If you breathe in carbon monoxide, that's not great for you. If you breathe in carbon dioxide, which is CO2, you're totally fine. All of those carbon bonds are all connected to the oxygens, very stable molecule, nothing to worry about. In fact, CO2 we intentionally put into carbonated drinks to make it fizzy. And it's, again, that makes the drinks a little bit acidic, but the CO2 itself, the little bubbles, there's nothing to worry about with that, right? So it's so harmless that you even put it into things that you drink, and it's fine. CO2 is also in fire extinguishers, because CO2 is not oxygen, and so you can use it to put out fires, that sort of thing. Again, CO2 in and of itself, really no big deal. You might say we're using it as a tracer of the thing that we're really interested in, which is, you know, how many viruses or bacteria might be in the air, that sort of thing. But it's very hard to measure that, right? It's hard to take a sample of the air and, like, you know, break down all the viruses and do the DNA of all the viruses and all the bacteria, things like that. That's really hard. That's really expensive. This thing you can get for about $45 from Amazon. You can walk around the school, it instantly tells you whether the risk is high or low. So we like these. So that's one thing to say. So here's a soda machine, and you notice there's a CO2 canister down there. I noticed at the store the other day you can actually buy CO2 canisters, because some people like to make their own seltzer water. I'm a big fan of seltzer water myself, and so some people will buy a CO2 canister. But the CO2 combines with water and syrup to make the flavors there. And so that's the genius of soda fountains, is that you're using the tap water to make soda rather than just shipping each, making the soda at a factory, then shipping it around. And then, like I said, some people go to the airport and they measure it, and so this is somebody sitting on a plane, sort of freaking out a little bit that the number is so high. So let me just real quick show you the Amazon thing. Again, we're not getting paid for this, but I just want to, for the sake of showing you, there's a reason why I feel like this is important to say. So when we did this the first time, we bought a different sensor, and we found this sensor, and I'm not going to say which one it is. We found a sensor that was about the same price as this, but it measured like 15 different things, and we're like, $45 to measure 15 different things, fantastic. And then it arrived, and then it was terrible at measuring CO2 levels. So it was terrible because it was too cheap, essentially. It was a cheap product, and we were too cheap to spend. So here's the thing, is that the lesson learned is if you're buying a product that does like one thing, it's probably going to be pretty good at that thing, right? And so this is a CO2 sensor. That's the main thing it measures. It also measures temperature and humidity, but mainly CO2. And it does a pretty decent job of it, and it's only about $45. So if one of them gets destroyed, it's not the complete end of the world. So this is the one that we recommend. There's probably others that would work fine. Just in general, we discourage you from buying the ones that measure like 6 or 7 different things. And another thing I'll say is if you go on YouTube, you will find people that actually will evaluate the sensors. There's a whole like hardware YouTube, right? So where people test out stuff, and so you can decide whether to buy it. Take advantage of that. And so, these ratings aren't perfect here, but the thing you want to notice, if they're complaining about the battery life, but they're not complaining about the accuracy, you found yourself a good sensor, right? Because we're scientists. We want this thing to be accurate. If the battery life is like a year, but it's inaccurate, who cares, right? You don't want that sensor, right? And this thing will stay running for hours. If it's got a USB connection to charge it. It's fine. If the battery doesn't last more than a year, it's not a big deal. But it's just make sure that it's actually accurate. So again, this is the one that we recommend. No one pays us for that, but this is yeah. So take that for your consideration. All right. So the plan is that. Yeah, so let's talk about this thing. What is it? What do we do with it? What's the number that it measures, right? So the number that it measures, and this is a fun activity to have for the class. Like, what do you think ppm stands for, right? Well, ppm stands for parts per million. And so for every 1 million particles of air, there are going to be 608 of them, or for me right now it says in this room it says about 1,000. So for every 1 million particles of air in this room, there's about 1,000 of them are CO2, and the rest are going to be a mix of nitrogen molecules and oxygen molecules for the most part, right? So in the whole scheme of things, that's a pretty small component of the air, right? Relatively small component of the air. If you take this outside, you will find that instead of being 1,000 like it is in here, you'll find that it's about 400. So the atmospheric level of CO2 is about 400. There used to be a big climate change advocacy organization that was all about 350 parts per million. They were very concerned that we don't exceed 350 parts per million, and we did a few years ago, but that's another way that this number comes up. So again, CO2 is harmless in and of itself for human consumption, so breathing it in, breathing it out, especially at 1,000 or 2,000 or 5,000 parts per million, not a big deal. But of course in the atmosphere it will CO2 molecules absorb more, and this is not a part of the activity really, but it sort of sets up a little bit for the Earth Day activity that I'll talk about in a second. But CO2 molecules absorb more infrared light than N2 molecules or O2 molecules. And so as a result, you get this greenhouse effect, which I prefer. The greenhouse effect assumes that you have grown up around greenhouses. I didn't grow up around many greenhouses, so I grew up in Florida, in which you really have to worry about when you park your car and put your windows up, right? So I prefer to, so instead of the greenhouse effect, I refer to it as the parked car with closed windows effect, in which you have sunlight coming in, and then the glass is preventing the infrared light from escaping in much the same way that it would in a greenhouse. Anyway, the point is that CO2 has a profound effect on our climate, which we'll talk about in the next activity. But in terms of breathing it in, breathing out for humans, not a big deal. Really, it's not harm. It's a very stable molecule. It's not going to mess with your insides, right? So that's what it's measuring. It's measuring the concentration of CO2 in parts per million. And if you look at this little sensor, when it's around 600 or so, it gives a green thing. Mine, which is right now, it's at 117. Sorry, it's at 1017. If you look closely, it's in the yellow. And then if you read the manual for this thing, it says that if it's above 1500 or 1501, then it goes into the red. So red is bad, 1000 is okay-ish, and then 400, 600 is pretty good. My classroom at Ohio State is often around 800, which is pretty good. And I'll tell you in a minute what we sometimes found in the classrooms that we went into. So here's a question: how many parts per million would it be 100% CO2? Well, if for every 1 million particles of air, if all of them were CO2, then that would be 1 million. That would be 1 million. So for what we're measuring, this is a very tiny fraction of the air there. So a practicality with these things is that it does take a minute for it to come online. So when it first turns on, it's going to say 400 because it's assuming that you might be outside. There's pretty much nothing you can do to go less than 400, as far as I know. But you have to kind of wait 1 or 2 minutes for the concentration to stabilize. And the idea is that you're going to go around the school measuring these things. Now, your students, a tricky thing about this is that as I'm talking here, and I think this is even, if you go back and you review the video, you'll notice that like this started right under 1000 and now it's at 1100. So as I'm talking, I'm probably breathing out more CO2, and because I'm next to this thing, it's going to sense that, and so as you talk, it tends to go up, and so that's something to be mindful of as you make measurements, because you might find that the measurements go up and up and up. But what you can do is you can measure it multiple times. You can have multiple student groups measuring it. You might want to be careful to just sort of like keep it away from your mouth a little bit to make sure that it's fine. And there's this question cycle, right? So there's this data cycle of asking questions, looking at the data, analyzing the data, reformulating the questions, gathering more data. And so you might want to ask yourself, like, what might we actually find? What might we, what would be concerning? What would not be concerning? What would be an uninteresting result? And when we were doing it at the school that we were doing it at, what I thought was going to happen was that in the classrooms, I thought the CO2 was going to be highest in the classrooms. I thought it was going to be lower in, say, the hallways, in the common areas, and that is what I thought we would end up seeing. And then a shocking result, I think, would have been, again, this is before we took the data, a shocking result would be like, maybe that's just high everywhere. Like this thing turns up as red if it's above 1500, What if it's above 1,500 in the entire school, right? What if if the danger of virus transmission and bacteria transmission, airborne, is just like across the board very high? And so that's something to think about. You can also have discussions about, well, if it is, even before you do it, the experiment, if it is high, what are we going to do about it? Are we going to mask up, right? So I often put on a mask before I go to the grocery store, even today. Most of the time, 95% of the time I don't put on a mask, but I put it on to go to the grocery store. I put it on in the airport when I'm flying. So maybe we should mask up. Maybe we should mask up, especially during the winter when the flu is going around, right? Maybe we can open up windows, something like that. These are discussions we could possibly have even before taking the data, so that we can have, because the purpose of taking the data is to inform, things that we're interested in, right? So the first thing we asked them to do was to actually just everybody sit in their desks and take data with this thing, and just what range in this room do you actually get? And you find that there can be a surprising range of values just for the students all sitting in the same room. If you look in the manual for this thing, it says the accuracy is plus or minus 40 parts per million. So what that means is that mine is reading 100, 1,000, 117, but really it's only maybe the first two digits there that are actually that it's confident about, if that makes any sense. Yeah, so plus or minus 40 parts per million, plus 5% again. So something to think about that. The accuracy goes between 400 and 250 parts per million. So if it's measuring 250, I guess it goes up to, I guess it can't go above 5,000 parts per million, that sort of thing. So it's just something to think about with what this thing is actually measuring. And I think what we found when we had the students sit in a room and doing it is that sometimes the measurements were high, but perhaps those were students who were like standing next to it, kind of breathing on it. And when you do that, it will, when you do that, that does tend to make it go up, if that makes any sense. So just think about that before you send folks. Yeah, look at that. So I breathed on it just now, and it's gone up to 18 and 19 because I've been breathing so close to it. So it's something to be careful about. Yeah, look at that. It's all the way to 2,000 now. It's in the red now because I was breathing on it. So you want to be careful about those sorts of things. Yep. And you have to decide whether you want to measure each room multiple times, take the average, that sort of thing. And then you can go out and measure the CO2 concentration. I love this Star Trek shot with a tricorder. You want to give them advice to make sure to not interrupt the other classes. You want to give the other teachers a heads up that students are going to be walking around measuring CO2 in the school. Is what you're going to do. And then you want to write down the different room numbers. You also want to do outside. Outside is probably going to be 400 parts per million. If it's not 400 parts per million, that's something a little bit to worry about, right? But you want to go ahead and collect the data. And I believe that's about it for the slides that we have. And so you want to go and you want to collect the data, and then you want to go and put it into some sort of a spreadsheet, like so. So here is just, this is not real data. I just sort of came up with this. This is kind of fake data. And so your students, maybe you can make a spreadsheet where your students can all fill this out collaboratively, or have multiple measurements and take the average of it. So taking the average is a good practice for spreadsheets and that sort of thing. And so you want to have one sheet that has the room number and the measurements and the average. And then what you can do is you can take, you can sort of highlight a cell here. So I'm going to highlight this cell. So I'm going to Control-C to copy the contents of that cell. And I can either paste the specific values, or I can actually just paste the actual link to it, if that makes sense. So now instead of just being 2,000, it's going back to sheet 1 and pointing at B3, that sort of thing. So the reason you might want to do this is because you have this list of rooms, but a fun thing to do would be to make sort of a picture of your school in Excel. And then in a minute we're going to make this thing light up according to how much CO2 concentration there is. And we designed this activity, a big motivation of it was something from this study guide. So a thing that you can choose to do is to encourage your students to take the Microsoft Excel certification exam. There's two different levels. One is you probably want to encourage them to do the introductory level. There's another advanced level. The introductory one is, it's involved, but it's not the hardest thing that they're ever going to do in their entire lives, I think. And a lot of it is pretty straightforward stuff. And so the part of the idea we had for this activity was from this page from their book. I won't show you the whole book, and I won't give you the PDF for the book, but it's pretty straightforward. It's relatively inexpensive to purchase. And this was an activity that they encouraged people to do. They wanted to have what's called conditional formatting, which means that the color of each cell depends on the value in each cell. So you write a conditional statement, so in other words an if statement. If the value in the cell is between such and such, then make it green. If the value is between something else, make it yellow, make it red, that sort of thing. And so this is a core part of what students would need to do in the Excel Industry Certification exam. And so it's something that we did in our thing. So this is what ours looked like. So we took all this data. Again, this is fake data. But we took all this data and we, maybe your school is structured like this. So there's it's not obvious that room 119 would be next to room 100, but you can structure it that way. And then we got it to make different colors using the conditional formatting, which in Excel has to do with this. I believe there's something similar in Sheets. But this little icon here is where the conditional formatting is. And so what you can do, and you can see in a nutshell what we did with that. So there's 3 different conditional things. So if it's and there's different ways to do it. So what we actually did was that we said, all right, well, go ahead and here's your conditional formatting. You can click anything in here. But your goal is to try to get it to light up such that if it is below 1,000, then you want it to be green. If it's above, If it's above 1,000, you want it to be yellow. And if it's above 1,500, you want it to be red. Which, by the way, is the same scheme that's used in this thing, right? And so so you can let them kind of flail around a little bit. And so I think that's important, is that you can let them just sort of say, all right, well, I want to do greater than. So they might say, okay, well, greater than, I want to do red, or less than, less than, I want to do green, that sort of thing. Because there's multiple ways to do it. And then there's also there's the color scales. They might put in the formatting, and then the color scale might do the high stuff is green, whereas the low stuff is red. They might flip that. So let them play around with this for a while. Let them squirm. Let them struggle a little bit. Don't just tell them what the answer is, like I'm about to tell you. But so what you can do is you can put new rules, and you can put, if the cell value is, let's see, greater than 1,000, and then you can add, what is it? I think if you, yes, you can add a couple of these things in here. And so this one is, let's see, how do I do this one? Yeah, so cell value is between 1501 and 5000, make it red, that sort of thing. If it is between, if it's between 1001 and 1500, then make it yellow. Why does this work better than greater than and less than? Long story, but that's what we found actually does work. So that was the activity that we had them do, and And then you can talk about the results, like is there a hot spot? Is there one end of the building that has higher CO2 than the other end of the building? And the thing that we found when we did this was that the CO2 is sort of across the board quite high, higher than we expected it to be. I think it was over 2,000 parts per million. And I expected it to be lower in the common areas, and it tended not to be that much lower. So we got almost the same. We tended to get, you know, in the 2000s for many of the measurements that we did. And so this fake data, you know, bounces around between 800 and 2,000, that sort of thing. Our data tended to it was very hard to find things in the 700, 1,000 zone, essentially. That's what we found, which is maybe evidence that the students should be masking up during the winter or not. Again, it's entirely up to your interpretation. But some people would say that, okay, well, in the winter, the humidity is lower, and if you look at the wastewater data, if the COVID is in the wastewater data, then that combined with this, that is actually a pretty good reason to mask up. So that's what I tend to do. I tend to mask up when the wastewater data is really high, and if the wastewater data is low, I don't mask up hardly at all, except maybe when I go to the grocery store or the airport. So anyway, so that's the kind of conclusions that we had. At some point, we should try to make a worksheet where students can fill this out. We didn't really provide them with a worksheet. We just sort of asked them to fill out the sheets there. But we thought about doing that. We just didn't have time. So that's the basic idea of the CO2 thing. So let me know if you have any questions about that. But again, our dream is to have a data science course that allows that well-prepared students to take the Excel Industry Credential exam, if they so choose. So that's CO2. The next thing is the Earth Day activity, which is here. There we go. So we made this a while ago, and I mean, on some level, this is one of the first, maybe even the first data science activity that we did. And I am very grateful to collaborate with the University of Mount Union on this one. So the students that did, you know, a lot of this work were from Mount Union, and they made the videos and all this stuff. The videos were recorded at Mount Union. And the unfortunate news that I have to break is that since we released this video, maybe you've seen it on the YouTube channel, when I originally designed this activity in probably 2017, I believe the global average was 1.4 degrees Fahrenheit warming. I believe now we're closer to 2.4, which is a bit sad. But the purpose of this activity is that some places of the world, the effects of climate change are very obvious. And by that I mean, like in California, where you get all these wildfires, in Canada, where there's been all these wildfires. Or you see icebergs melting, you see sea levels rising and flooding and things like that. For us in the Midwest, the impact of climate change is a little bit less obvious. It's definitely happening, but it requires a little bit more thought and pointed data to see what's going on. Each year it gets more obvious. Each year it gets hotter and hotter in here, and I hesitate less when I say that. But the point of this activity is essentially to ask, you know, if you're in the Midwest, it's cold during a good chunk of the winter, right? And so the question that we're trying to address is that due to climate change, how many fewer days with sub 32 Fahrenheit weather do we have, right? How many fewer frosty days do we have as a result of climate change? And so that's our question, right? Remember our data cycle here? That's the question that we ultimately want to address. Sitting there right now, you can tell me on the chat, how many days do you think we've actually lost in the Midwest, days per year? So days that, it used to be there were days that were on average 20 degrees, right? maybe we don't get those days anymore. So how many days of frosty weather do you think we've actually lost because of climate change? So that's the point of this activity. Now, if you live in a warmer climate, and I grew up in Florida, and so I know about that. If you live in a warmer climate, there is a way to modify this for you. And the question that matters for you in a warmer climate, especially in a place like Florida, is mosquitoes can reproduce if the temperature is above 50 degrees Fahrenheit. And so a very important question for people in the South is, how many days of sub 50 degree weather did you have last year? And how many of those days have you lost as a result of climate change? Because every day that you lose is a day that you gain in mosquito reproduction, which is not so fun, right? So there's a way to modify this activity to do that. But the first thing you want to do is that you want to go to Google, and you want to, and a cool part of this activity is that you can adapt it for whatever city that you're in. That's an important point, right? So, so you can do climate data for whatever city that you're in. I'm going to do Cleveland. The activity talks about Columbus, but I could do Cleveland. And this sort of data comes up, and then you can just click graphs and see what the annual variation is. And the first thing you do is you try to take the average of these two numbers to try to figure out what's the typical warm day of the year, what's the typical cold day of the year, that sort of thing. And then, so for Columbus, the warmest day of the year, noon of the warmest day of the year is about 75, and then noon of the coldest day of the year is about 28.5, something like that. This is not exact, but it's sort of roughly correct. And then you can go ahead and you can open up the code in the editor. This will work in other browsers, but it works best in Chrome just because of the way that the text appears on the screen. And you can modify these numbers if you want to. And the basic idea of this is that there's, it's warm in July, it's warm, in June, it's the coldest in December, January, February, for example. And it's taking this curve, which is the average temperature through the year, and it's adding a shift to it. And as it adds the shift to it, it counts how many days of sub 32 Fahrenheit weather do we have. And you can watch it go from something like 64 days a year of sub 32 weather to, as the temperature increases, to 58 and 54, and if you wait here long enough, eventually there just won't be any days of sub 32 Fahrenheit weather. And you can see the numbers. This is the plot of how many days have been lost. You can kind of see it marching up that way. So I like this activity because I've been living in Columbus for 15, 17 years. But I've heard stories about what Columbus was like in the 1970s, or what Ohio was like in the 1960s and 70s, when all the ponds would freeze over and people would ice skate on all the ponds. People would walk across the Olentangy River, things like that. And it's just unheard of today. And there's there's almost no sledding in the winters anymore. And then there's very rarely do we have ice skating on ponds in central Ohio. And so this kind of gets at that. Now, where's the data science part of it? Well, what you can do is you can, for fun, you can add some randomness to this. And so you can use this copy code button, and you're going to add this random function to a particular line in the program. So I'm going to add it to this line. So I got to get it exactly the right place, right? Because I got to get it before this semicolon. And then I'm going to add that. And what it's doing is that each day it's going to make the temperature fluctuate up by as high as 10 degrees or down by as high as 10 degrees. So in principle, from one day to another, you could have as much as a 20 degree Fahrenheit shift, which if you live in Ohio, you know that that's very, very possible. So. And maybe you want to adjust these numbers to get better. So now we have this fluctuating temperature, which is at least slightly, somewhat inspired by real temperature data, and you can try to see if it's realistic or not. And we're adding just a shift to that. Now the real data is it's not as clean as that. We don't know exactly what things would have been if climate change wasn't there, but you can see how there's sort of these noisy trends still in the data, even with the randomness. So that's the basic idea. And then what you can do is you can add a little bit of code here, and you can download the data at some point. Let's see, I think I'm going to put it here. So you can add some code here, and when the temperature gets to some value, and it could be 1.4 or 3 or whatever you want to do, and then it will save to your computer a CSV file, and you can go and you can open that CSV file in a spreadsheet program. There it is. And you can do things, we talked about that sort. We did a sort yesterday with the night sky simulator. You can sort the data and see, how much hotter is the hottest day of the year now that there's climate change, that sort of thing. Now, this activity doesn't get into why there's climate change. It doesn't get into the greenhouse effect, or as I call it, the parked car in a parking lot with the windows closed effect. But you can still, you can, as a teacher, you can add that to this activity as you like. A complicated fact is that a lot of the temperature increase is because of greenhouse gases, but in places like Columbus, where you've had a lot of concrete, that's also a reason why the temperature has gone up considerably. So those two things are mixed with each other, and but that's up to you to discuss. So this activity doesn't explain why the temperature is going up. It just says the temperature is going up. What is the effect of that on the seasons? Now, a cool thing you can do when you're towards the end of this is that there's this picture is a little bit out of date, but there is a climate research center at a university which also happens to have a football program, and so they have some, let's see, I think I was gonna, did I mess that up? So they have here, I just looked this up. Yeah, publications and products. So on this page here, so you go to our work, publications and projects, right there, they have this map. And what it allows you to do is that it allows you to see their reports on different cities that are adjacent to the Great Lakes. And so, for example, they did a report on Toledo, Ohio. You can feel free to look at any one of these things. And so you can view the fact sheet, and it will tell you, for example, that it thinks that there's 29 fewer days below 32 Fahrenheit. So they think that the increase in temperatures, they think temperature's gone up 3.2 Fahrenheit here. So you can put that in your program, and then based on that, they think that there's 29 fewer days below 32 Fahrenheit. So my grandparents are from Ohio, right? So since they were alive, we have lost almost a month of frosty weather in Ohio. So it's almost like the month of January that they knew doesn't exist anymore. We just jump straight from December to February. And we get an extra month in the summer, so to speak. So it's about a month of weather that's just lost to climate change. Even in Ohio, which is regarded to be like this climate-resistant place, right? So anyway, so that's the kind of fun things you could do, and it's an interesting challenge with your students to try to see, can you corroborate this number? Does your program actually match up? And when I've done it, it actually matches pretty well. But let us know how that looks. So that's the main upshot of it, and you can view, there's videos embedded in this thing, or you can just watch the videos on the YouTube channel. There's a lot of fun stuff that you can use this for. Other extensions to this include you can change it to 50 Fahrenheit for mosquito populations. You can also change it, I don't know if we still say it this, you can change it, the temperature that sea ice freezes is I think like 28 Fahrenheit or something like that. So you can also use this to assess to what extent sea ice might be affected by this, because people worry about the ice melting and the sea levels going up, which is very important. So there's all sorts of extensions of this thing. But the basic idea is that you've got a good data set, you've got a kind of a model here, and it's really up to you to what extent you want to talk about the fact that there's a cosine function here. If you want to skip it entirely, that's fine. But again, a criticism of high school data science is that it does not connect with Algebra 2 level stuff and higher math stuff as much as it could, and so that students might not be as prepared for college. And so talking about these trig functions just a little bit could be an important thing to do. So just take that in consideration before you just sort of brush over that. So I think that's about it for today. But yeah, let me know if you have any questions in the chat or on Discord, and yeah, I hope you